All right, everybody, Friday, November 13th. Today I can use the Pythagorean theorem to solve real-world practical problems. So like everything else that we've done this semester, it always comes down to practical problems. I'd also like to point out, last time we were in school on a Friday the 13th, school got shut down. So let's hope that everything's going to be okay today. All right, just to start off, you're playing golf. You go 120 yards down, hit a straight shot, and then you still need to get 50 yards to the green. Well, what's the fastest way to the green? Right? You risk it. You shoot a high loft over this water and bam, right onto the green, Tiger Woods style. That's the shot the pros would make. If I was playing golf, I would go the long way. But what we're going to talk about today is this best route, right? And you'll see that this kind of looks familiar if I was capable of drawing a straight line. And this kind of looks like it could be a right triangle. So what we're going to do is we're going to kind of force it into being a right triangle. And in this one, we'll be looking for the hypotenuse. All right. Now, I'm pretty sure on the test, they give you a picture for all of them. But as you go on in math, they're not always going to give you a picture. So you're going to have to kind of be able to draw your own picture. So we're going to read our questions and then look at our picture and figure out what we need to solve for. So Mark's on his way home from work. He drives 35 miles due north, right? 35 miles up north, and then 42 miles due west. Find the shortest distance he can cover to reach home early. Now, this is, of course, assuming that Mark's not driving on any real roads. He's just driving through a cornfield somewhere, because I'm pretty sure that if I left my house and went to my friend's house, if I took a straight line, I'd run in through a couple of houses, and I don't think my neighbors would appreciate that. But in theory, we're going up north and then straight west. So that's where we can claim that we have a right triangle, right? Since we're going to put our right angle symbol. Sorry, it's buffering. All right, remember, we know that opposite of that is going to be our hypotenuse. So we have a C here. We don't know what C is, right? Our biggest thing when we're doing these problems is just labeling everything, getting all of the information. And once we have all of that, then we can just use everything that we've learned this week. Well, I'm going to know that my A is going to be 35 because that's smaller. Like I said, I like to put them in order. And my B is going to be 42. So I know my formula is A squared plus B squared equals C squared. But like yesterday, we figured out a formula, right? And that was that C would equal the square root of A squared plus B squared. And that's when we put in our A, put in our B, and what it's going to do is going to spit out our answer. So let's go ahead and do that in Desmos. I should remind myself next year that I should put these questions in order so I don't have to always keep rewriting my equations, but it is what it is. All right, so we know that A equals what? A equals 35. And we know that B equaled 42. Wow, that is an ugly number. Did I put everything in right? 35, 42, 35, and 42. So that looks right. Find the shortest distance he can cover to reach home early. So C would equal 54.67. I'm just going to round to the hundredths miles. So that would be our value for C. Right now, I would encourage you guys, especially when you get a number like this, just check it. Right, so if I were to check this, let's see, if I would go 54.67174, this is obviously a irrational number because it's just going to keep on going. And if I were to square that, I get 2,989. And if I have, remember, I'm going to take my 35 squared, and I'm going to add my 42 squared, and you'll see that we do, in fact, get the same answer. All right, and that would be the same if you were to have written it all out. Just a fact real quick, that if you truncate or you cut it off, you round off at the hundredth, and you go to check using this number, 54.67, you'll see, look, I'll show you, 54.67. Notice how you get this decimal. Now it's really close, but it's not spot on. And the math major in me would tell you that that's okay at this level. You know, if you wanted to check it with this and you were that close. I mean, you're talking less than 2/10 of an answer away. At this level, I would say 9 times out of 10, that's going to be fine. Again, the big part for us today isn't necessarily the math part. It's more so figuring out what we're looking for, because I have confidence that you guys can plug stuff into a calculator and that you know how the Pythagorean theorem works. All right, so Joshua won on a laptop at a school raffle. All good for him. The laptop screen measures 10 inches in height, 24 inches in width. Find the diagonal length of the laptop screen. All right, so just a little fact here. When you buy a laptop or a TV for that matter, and they tell you that it is 36 inches or 24 inches for a screen, they actually measure it from corner to corner. They use the hypotenuse going through from the top corner to the bottom corner of any screen. Anybody want to know why? That's because our hypotenuse is always the largest number. Now, if they told you your TV was 10 by 24 versus whatever this number is, and I'll come back to that point when I know what the actual number is. All right, well, we're going to assume that this is a right triangle and that we're looking for the hypotenuse here. So we know that's going to be C. Remember, I've got A equals and B equals. Well, I already have my formula written in Desmos. So I'm just going to plug in my A, which happens to be 10, and my B, which happens to be 24. And look at that. C equals 26 inches. 26 inches. C equals 26 inches. So look, if you're going to buy a TV, right? And I'm like, oh yeah, this TV is 24 by 10. Or if I just said TV's 26-inch flat screen, you'd be like, 26? Oh yeah, it's bigger, I want that, right? So this is kind of something to know. So when you're looking at a TV, now you know that it's not necessarily the width or the height. What they give you is the hypotenuse, going from top corner to bottom corner. Oh, this is my favorite question. It's my favorite question. All right, Joey made a sandwich that's 4 inches long and 6 inches high. I don't know what Joey's doing, but I don't know why he's standing his sandwich up. I don't know why the sandwich is 4 inches long and 6 inches high. But whatever, man. Whatever. You get it, Joey. If he cuts the sandwich in half as shown in the figure, what would be the diagonal length of the sandwich? Again, I don't know why he's standing it up to cut it, but it's what he's doing. Well, again, we're going to assume that this is a right triangle. You kind of visually see it. We don't like to do this, but with these word problems, it's assumed. And you can see that we're looking for the hypotenuse again. So I'm looking for C. I know that A is 4, and I know that B is 6. Now, some of you guys probably already know this one. Some of you guys probably already know this one. But let me go ahead and type in my A, which is 4, and type in my B, which is 6. And I lied. Nobody knew that one. That was not a nice Pythagorean triple. But your C is going to equal, I guess it's not going to stay there like that. But your C is going to equal 7.21. I'm going to call it at the hundredths. Again, when you get a funny number like this, I would check it. Remember, just check it by plugging all your numbers back in to our original formula. But that's going to be the diagonal length of Joey's stand-up sandwich. All right, so we got 2 more, I believe, with the hypotenuse, and then we're going to come back and do, actually, you know what? I'm just going to do 1 more with the hypotenuse because I think we all get the point. Let's do this tree problem. I like this tree problem. All right, a 15-foot tree casts a shadow that is 8 feet long. What is the distance from the tip of the tree to the tip of the shadow? So you guys can use this like when you're standing outside and you see your shadow. Like sometimes like in the summer at the end of the day, depending on where you are, your shadow's like 9 feet long. You look kind of like Slender Man or whatever. All right, so we're going to use that same concept but with this tree here. So we know that this tree is 15 feet tall. We know that it's 8 feet. The shadow is cast 8 feet onto the ground. So notice how this visually, you see that it's 15 is kind of like outside of the tree. Well, remember, that's from the top of the tree down to the base of the tree. They're just not going to write this right in the middle for you. So that's where our right angle is going to go. I haven't really pointed this out, but you wouldn't write a right angle here. It doesn't even look right. Right? It doesn't look like it fits. So when you have these word problems, it works where it looks like it's going to fit. All right, and we're going to look for our C again. Well, I'm going to have A for 8, B for 15. Again, real quick, hop over here to Desmos. A equals 8, that's a 9. A equals 8, and B equals 15. And you'll see that the distance from the tip top of the tree to the tip top of the shadow on the ground is 17 feet. All right, let's do one more. And this one's going to be a little bit different, so I'm going to clear out Desmos. Probably should have had a couple more problems like this on here, but I don't. So an anchor line for a tower needs to be replaced. The tower is 96 feet tall. The anchor line is 105 feet long. How far from the tower can it be placed to the nearest foot? All right, so this one kind of shows us that we're not always going to be looking for C here, right? Look, this is where our right angle is going to be. Like I said, it doesn't look like it fits here. It doesn't make sense here. We're looking for where you get a 90-degree angle, right? All right, so we know that this is our C. So C equals 105 feet. Remember, I say if we're looking for a leg, I'm always going to give the one that we know A, and we're going to look for B. All right, well, we have a formula for this. We figured out a formula for this. And that formula was the square root of C squared minus A squared. Notice that what we're putting in there are things that we have, and we'll have A equals and C equals. Well, we know that A is going to equal 96 feet, and we know that C is going to equal 105 feet. So the distance from the tower to where the anchor line should be placed, so that way the anchor line's taut or tight, is going to be, B is going to equal 42.53 feet. And again, I'm rounding at the hundredths. All right, one thing I want to show you here. Let's say you get your A and your C mixed up. Let's say I went 105, and then I put in a 96. 96. You're going to get this undefined. And we don't like that in math, or not at this level at least. We love it in calculus. We don't like undefined at this level. It means we don't know what's going on, right? Well, what the problem is that's saying that we have a negative number underneath this radical, right? So look, what if I go negative, I just put a -1 in there. You cannot have any negative numbers underneath your radical. Not at this level. Or any level. Any level? A complex teacher would be very disappointed in me right now. Right, but we're not going to have, no, because you would have it, yeah. Anyways, at this level, no negative numbers underneath the radical. That's that. All right, so hopefully that was helpful. If you guys have any questions, feel free to reach out. Enjoy your weekend, and I will see you guys on Tuesday. We got a test next week.